In this demo, I'm going to solve the same machine learning problem 3 different ways in Google Cloud. So this is a text classification problem, one of the harder machine learning problems. And I'm going to solve them using BigQuery ML, using AutoML, and using a custom model that you write in Keras. And this way you get an idea about what the development workflow is for all 3 of these ways. And we will look at the performance of all of these methods. The problem itself is this. Suppose I give you the title of an article. Let's say I give you a title of an article and I said, where is this article from? Is it from the New York Times? Is it from GitHub? Is it from TechCrunch? And the question is, are you able to tell, right? So let me, for example, let's just go, can you tell? Let's just go to New York Times today. Okay. And let's say we picked up pilots of doomed flight or Ethiopian Airlines pilots followed Boeing safety procedures before crash, the report shows. If I told you this title and I said, does this come from TechCrunch or does this come from New York Times? I think most of us would guess it comes from the New York Times. That's because we see these words and say, these kinds of topics tend to be covered more from New York Times than in TechCrunch. Well, that's what we want our machine learning model to know. Now, how would you write a set of rules to do that? That's super hard. But if we had a data set of past headlines from the New York Times, from GitHub, and from TechCrunch, we can train a machine learning model to do this. And that's exactly what we're going to do. It turns out that when we go to Google BigQuery, okay, so we leave that here. Let's go to Google BigQuery. So down here is in the Big Data Tools. There's BigQuery. We can go into BigQuery, type in our query. So in this case, the data is in a BigQuery dataset called BigQuery Public Data Hacker News, and all of the stories, and we'll get the URL and we'll get the title, and let's get about 10 of them. You see that the title could be things like mobile first is dead, considering worthwhile branding, etc. And there are URLs like www.dasboom.com, www.covertimes.com, etc. So if we look at the URL, we can kind of figure out which publication it came from. So what we'll do next is that we'll write a slightly more complex query to do regular expression matching on the URL and pick up the title, and we'll try to find publications that came from the 3 publications that we're interested in. So here is a slightly more sophisticated query, which basically takes the title, removes all special characters from it, keeps only the words from the title, and then goes ahead and takes the URL, and if it says www.nytimes.com something something, it just keeps nytimes. So it does that, and then we basically keep it to be just where the source is one of these 3 things: GitHub, New York Times, or TechCrunch. And then, in this case, I'm taking the first 5 words of the title. And that's basically going to be my data set. It's going to contain the source, and it's going to contain the 5 words. So this is a BigQuery query. It's a SQL query that we are running on the data set of Hacker News stories. And at this point, we get that the source is GitHub, and the title is GeoIP module on Node.js now something, 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 right? So we are keeping the first 5 words. Now let's go ahead and train a machine learning model that if you give it the first 5 words of the title, it would tell you whether the article comes from GitHub or New York Times or TechCrunch. So the whole idea here is that once we know the first 5 words of the title, we will be able to tell, right, which publication this article appeared in. So we are training the model based on historical data. So we come to this query that pulls the data, and we need to add a little bit of SQL to it. And the little bit of SQL is create a replace model advanced data.text class. So advanced data is the name of my data set. So what I'll go here, I'll do is I'll go into this thing and create a data set. Create a data set called ADV data and create the data set. So into this data set, I'm going to create a model called text class. It's going to be a logistic regression model. So it's going to do classification, and the label is a source. Remember the GitHub or NY Times or TechCrunch, and the rest of it, in this case, the 5 words, they form the features of the model. I go ahead and say run, and this is going to go ahead and train a model for me. So this took about 3 minutes, and at the end of 3 minutes, in my advanced data, there is a new machine learning model called text class that has been created, and the text class basically got trained, and right? So we basically have information on, as it got trained, how much each iteration took and what the training data loss is. Well, this is fine, but what we can also do is we can actually have it tell us about the evaluation of this model. So let's say select star from ML evaluate advanced data.text class. And when we do that, we learned that the accuracy is about 79%. So 79% of the time, if you give it a title, this model is going to correctly predict which publication the article in question came from. Let's try it out. So in this case, what I'm doing is that I'm saying, suppose I have an article that starts with unlikely partnership in house gives. Which publication is it going to come from? Or Fitbit's fitness tracker is, or downloading the Android Studio project is. And remember this article from today that I picked up about the Ethiopian Airlines. So we can do that too. Ethiopian Airlines pilots followed, and what was the title? Followed Boeing's. Okay, so let's do that and hit run. And it's now going ahead and doing a prediction, given the title, which is the potential source of this data. So it says that an article that starts with government shutdown leaves workers reeling is most likely from the New York Times, almost 48% likely New York Times, 26% GitHub, 25% TechCrunch. Unlikely partnership in house, also New York Times, 50% likely there, 25% for the other two. On the other hand, Fitbit's fitness tracker, most likely from TechCrunch. Downloading the Android Studio project, it says most likely TechCrunch. It's wrong. It's actually from GitHub. But you can see that it gives approximately equal probability to both TechCrunch and GitHub. How about the article from today? Ethiopian Airlines pilots, New York Times. Okay, let's see. Yeah, that's from the New York Times, again, with a slightly larger probability. So that's one way of doing machine learning, right? You basically have your data in a data warehouse. You're able to use SQL and train a text classification model that does pretty well, 79% accuracy. The second way on Google Cloud Platform is to use AutoML. The idea behind AutoML is that you can go down to the Cloud AI platform in the natural language, and get started with AutoML. And in this case, I'll fast forward a little bit because AutoML takes a few hours. So in this case, essentially what we did was that we loaded up a training data set, and we pointed it at BigQuery, and we said, load up the data, and it loaded up 35,000 titles from GitHub, 26,000 titles that correspond to New York Times, and 30,000 ones that correspond to TechCrunch. And you see here an example of the kinds of titles and where they come from. So for example, it says access to iPad app, Flipboard, etc. that comes from TechCrunch, and so on. So it basically does that. And then we're able to go in the graphical user interface to say, go ahead and please train a model for me. And we can just click train a new model. And this takes a few hours, as I said. And then at the end of it, we basically get a model with training curves. In this case, we get a training curve that has, you can do a full evaluation, and we should get an accuracy that, like a top one, that is around the average of these things, which is around about 82% accuracy. So AutoML in this case gives us actually 82 and 94, so about 86% accuracy overall. So it gives us a much higher accuracy than BQML was. All that we had to do was to basically load the data in. It does all of the neural architecture search. It does a bunch of feature engineering. It goes ahead and creates a classification model. And once we have the classification model, we will be able to go ahead and do a prediction on it. And in our case, a prediction again. So let's go ahead and pick a happier title. So in this case, let's say, let's pick a title. Well, there are no happy titles. Let's pick this one. The Stoic Philosopher of the Lockup. Okay. So let's say that that's the title that we get. And where is this likely to be from? And it says 98% likely that this particular article comes from the New York Times. And as you can see, it's pretty good. So in AutoML, the basic idea is you load your data in, and then you click a button to train, and then you click a button to evaluate, and then you can basically, you have your model all deployed. You can pass in a new text thing, and it basically goes ahead and does a prediction. So that's a second way in which you can do machine learning on Google Cloud. Use AutoML. It has a bunch of predictive models, built-in models, in which you can bring your own data set and you can train a model on that data set. And it basically gives you a very high quality model to start. The third way to do this is to write your own model using custom models using Keras. In order to do that, what I will do is that I will go ahead and create a notebook. A notebook is something that that data scientists tend to use because it allows you to mix and match documentation along with code. So in this case, I'll go ahead and create a new instance. Now we are creating a new instance. And once this instance is created, we'll basically get this link that will become blue, and we'll be able to click on it and go into a notebook. So at this point, the instance is started. Jupyter is starting. Okay, now that we have the blue link, I'll click on Open Jupyter Lab, and this takes me into the notebook interface on the virtual machine. And what I can now do is that I can launch a terminal. So let's go ahead and git clone my repo. And now that the repository is git cloned, it shows up here. And we can open up a notebook that I have in the repository. So here is the notebook. And what I will do here is that I'll change the bucket and the project to reflect the bucket and project that I'm working with currently. I can do that by going to Home. And in this case, that's a project name. I had created a bucket with exactly the same name. So I will go ahead and use that bucket and that project. And this is in US, where is it, Jupyter? I started the notebook. You can go down here, ML Engine, notebooks, in US West B. So go down here, make that US West 1B, okay, and return. So notice that the notebook contains some text documentation that says what's happening. It's a report, but it's also executable. So you can share a notebook with someone and they can run the code. So it's executable. It's also serves as the documentation of the exact work that the data scientist did. So we've set the project and all of these things. We can set that on the command line. Let's look at what version of TensorFlow we have. And in this case, I'm running TensorFlow 1.13. And Jupyter comes with, now we have a cool, what are called Jupyter magics, a way to go ahead and run BigQuery. So we can go down here, for example, and say what I did earlier, the URL, the title, and the score. And I can now run the query from the notebook, and I can get the URL and the title and the score. So it's as simple as that. You put BigQuery in front of it and put your SQL in, and you get the result right there in the notebook. And in this case, this is the longer query that I had, where I was basically extracting out the source from the URL, etc. And we can now go ahead and make sure that that part works. And we see now we have a bunch of different sources and the number of articles from each. And in this case now, I'm basically getting just the GitHub and the New York Times and the TechCrunch articles. We can do that. And using that, I can now go ahead and create my training data frame and my evaluation data frame. The data frame here is a Pandas data frame. Pandas is a Python package for doing data analysis. So in this case, I now have two data frames, a training DF for training and an evaluation DF for evaluation. And they're different because I've kept 75% of things for training and 25% of them for evaluation. So at this point, I have those. We can figure out how many training files we have. And you can see that we have around 20 to 27,000 articles for each of the sources in the training set. We have about 7,000 of them in the evaluation set. And we can go ahead and save these to a CSV file on, right, locally or on cloud storage. In this case, we're storing it locally, right? So we're doing that. And we can now go ahead and see, here are the files that we have, right? The first one, this is the one from GitHub, next one, so on. We can find out how many lines there are. There are 24,000 lines in evaluation, 72,000 in training. So these are the kinds of things that a data scientist does in a notebook. They go ahead and they explore the data, they create the training data set, and then they move on to go ahead and writing the code in Keras. So I won't walk through all of this, but the Keras code is also in the repository if you're interested. So there is a text classification model. So in the trainer, there is your model.py, and Keras is a way of writing machine learning models. In this case, the key model here is, let's see, that it includes what is called an embedding to take words and convert them into numbers, has a convolutional layer to do a rolling average of the words, pooling them up, creating a dropout, creating a dense layer, which is almost a final layer, and then using that with an activation of a softmax, which is what you tend to do for classification. And then you go ahead and you submit that job to ML Engine for training. So now we don't have to do the training on this small machine that we're doing the development on, although we could. Now we could just run the Keras model locally, or we can submit the Keras model to the cloud, have it do the training, and then we can come back, we can monitor it, and then we can look at what the predictions are. We can try out different articles, what the predictions is, and you can deploy the model and so on. So essentially, the third way of doing machine learning on Google Cloud is to write the model yourself, right? With Keras, and then you have your own model. It can be a very sophisticated custom model with all of the things that you know about the data and your problem. So to summarize, 3 different ways of doing machine learning on GCP. Number 1, use BigQuery ML that allows you to do models in SQL, very fast, iterative approach. We trained a model in 3 minutes. We got a pretty good performance. So it allows you to iterate and experiment and build models extremely quickly. The second option, if you have a few hours, take your data set, load it into AutoML, let AutoML have at it. You will get an extremely accurate model that takes advantage of all of the machine learning models that Google has built before. It takes advantage of all of those architectures. It does a search among them. It does feature engineering. You get a really, really high quality model for very little work, for essentially a day of compute. So once you have that model, you can use that and you can deploy it, and that can be the thing that you go to production with. The third option that you have is that you can say, no, I want to write my own model in Keras, and you can, right? You basically start a notebook, and you have your GPUs. You basically create your notebook, you write your Python code, and you train on the notebook. And then once you have a model that trains relatively well, you do the training at scale on the AI platform. And then once that's done, you can deploy on the AI platform and you can predict with it as well. So there you have it. 3 different ways to do machine learning on Google Cloud.